Hello everybody. This video is going to be on solving a radical equation. It's for the block days work that we did. To solve a radical equation, I put the actual steps here. The book had a good way of explaining it, but I want to kind of elaborate on that just a little bit and then we'll launch into 4 problems. To solve a radical equation, follow these steps. These steps are kind of general and not always applicable, but it says isolate the radical, so get the radical by itself. So get by itself on one side of the equation if necessary. We're going to see this step in a little bit. Sometimes that's not always true. Sometimes you want a radical equal to a radical. That's one thing. Or a radical equal to a number. That's the two forms that you really want when you're solving an equation, and that's what step 1 is kind of talking about. And then to get rid of the radical, because your job here is always going to be to solve for x. To get rid of the radical, whatever this number is, put it up here as well, and that will get rid of the radical. And again, that will make sense when we actually do a problem like that, but that's what step 2 means. So raise each side of the equation to the same exponent. And then finally, and this is the most important one, when you solve the resulting equation using the techniques, check your solution. I cannot stress this enough because there are solutions that are called extraneous. And if you look at the first few letters of that word, that means there are extra solutions that are not actually solutions, and that's really important to note, that sometimes you will not actually get solutions. Like, it will give you a solution, and then that solution is just being mean, and it's just like, I'm not really a solution, haha. And you have to figure that out and before you actually circle your answer. So let's do a few problems so that way it's not so abstract and weird. So we got these equations here. Notice that one of these is a square root, one of these is a cube root, so we have to be careful with that. And our first step is isolate the root. So again, we need either a root equal to a root, or we need a root equal to a number. And here I have this 2 in front, but I want the root by itself. So I'm going to go and divide by 2 on both sides, and I get root x plus 1 equals 2. Second, I need to know what number is actually here. And the number that is here is a 2. Even though it's not there, it's actually a 2. And we say a square root, kind of like x squared, we have a 2 there. So what I have to do next is I have to then raise this, both sides, to the second power, or I'm squaring both sides. When I do that, I end up canceling out this root. So this 2 and that 2, they cancel out, and there's no more root. And I'm just left with what's inside, which is x plus 1. On the right side, I am equal to 4. Now solve. X equals 3. Now, again, and I cannot stress this enough, it looks like our answer is 3, but we have to check. Please make sure you're not doing yourself a disservice by not checking. Let's go and just check our answer, and I'm going to write it down, but you can just check it in your head if you want. So we're going to do 2, so this is checking our solution. Check. 2 square root of 3 plus 1 equals 4. Let's see if that's true. So I'm going to put a little question mark here because I'm not really sure if that's true. 3 plus 1 is 4 inside, so I have 2 times the square root of 4. And the square root of 4 is 2. And please keep in mind, if you weren't sure about this before, this is multiplication each time. So the square root of 4 is 2, and I do indeed get 4. I get that 4 out. Perfect. That's what I wanted. So my answer, to box it in, is x equals 3. Now we're going to go into the next problem. Again, we want a root equal to a root, or a root equal to a number. All right, and then once we have that, then we can go in and lift both sides to the power that we need. So here, I have a root minus a number equals a number, but I don't want that. I really want a root equal to a number. So what I'm going to do is I'm going to go ahead and add 1, just to get that cubed root by itself. So now I'm going to be left with the cube root of 2x minus 9 equals 3. Okay, now I have a cubed root. I have this cubed root, so I need to raise it to the 3rd power on the left, raise it to the 3rd power on the right, or cube both sides. And what I end up getting on the right is going to be equal to not 9. On the right, it's going to be equal to 27, because it's 3 times 3 times 3. On the left, so when I raise a cube root to cube, That cancels all of that out, and you're just left with 2x minus 9. And now you have an equation that you can solve, so let's solve it. Let's go and add 9 and divide by 2. And this is the part that you should, I hope, feel comfortable with, because you've been doing this for 2 to 3 years now, or more. And we get x equals 18. Maybe you can even do this in your sleep. Now, do not check, definitely check. Do not circle that answer. Let's check. So to check it, we're going to go ahead and plug it right back into the original one. So we're plugging it into here. And we're going to do the cube root of 2 parentheses 18 minus 9. And we want to see if that equals 3, because that's what it said it was supposed to equal. I'm sorry, equal to, yeah. Let's change this because that's kind of confusing. And then when we subtract 1 from it, it should equal 2. So that's what I really wanted. Okay, and we're going to see that. I'm not sure if that's true yet, so let's check. Okay, let's do the math here. So we got 2 times 18, that's 36. We got minus 9. And again, if you can do this in your head, that's good for you. Don't tell people because that's just mean. 36 minus 9 is 27. It's not mean, it's just showing off. Okay, so we got the cube root of 27 minus 1 equals 2. And now this part, we're looking for a number times itself 3 times to equal 27. I think that's 3. So we'll do 3, 3, and 3. So the cubed root of 27 is 3 minus 1 equals 2. We are good to go here. Yay! So our answer is x equals 18. Again, the whole point of the check is to make sure that the number that you plugged in on the left side equals the number on the right side. And you want to check that because, as you'll see in the next example, we could get extraneous solutions, which is not good for us. All right, next problem. We're doing good time here. Okay, this one. So I did say before that we want really a root equal to a root or a root equal to a number. And we kind of have that here. We have x plus 1 equals the root 7x plus 15. So we're set up here. So now what we need to do, our root is isolated. It's by itself. So we can just square both sides. Why am I squaring, Mr. Lakin? Great question. Remember, when there is no number right here, that is a 2. To get rid of that little 2, we have to do a big 2. Now here we have to do a big 2 as well, but we need to square everything here. So that's the new trick here, that when we have to get rid of a root, we have to square both sides. And when we square a number, that's easier. When we square a variable and a number, it's a little bit harder. Okay, there we go. So we got equals. On the right side is easiest because that's going to be 7x plus 15. If you're not sure why, it's because this root and that square cancel out and you're just left with 7x plus 15. It gets a little buzz cut. X plus 1 squared. Now I'm going to do some side work for that one with x plus 1 squared. X plus 1 squared is the same thing as x plus 1 times x plus 1. I am not going to distribute the exponent. Instead, I'm going to multiply these out as such, and I get x squared. And I get x times 1 is a plus x. And that's what I'm doing here. So if you didn't realize it before, I have to actually multiply this all out to get my answer, plus 1. So I end up getting all together x squared plus 2x plus 1. Hooray! All right, so now that's what I'm going to put on this side. It's 2x plus 1. Now I got to solve this. So this is a new step now, but an old step at the same time. Solve for x. It's a quadratic equation. Get x by itself. Not get x by itself. Set it equal to 0. Set equal to 0. So let's go and subtract 7x. And subtract 15. And you got this. We did this earlier in the year. We've been doing this a lot here. It just keeps coming up again and again and again. So we got x squared, we got a minus 5x, we got a minus 14 equals 0. You got 3 options. You can either, 1, you can factor if possible. Factoring doesn't always work. 2, you can complete the square. 3, you're going to do quadratic formula. Okay, for this one, I'm going to try and factor it. But if you cannot factor, you have to rely on one of the other 2 methods. Usually quadratic formula is the one students go to because it's just formulaic. You just have to plug in numbers. Simplifying is the tougher part of it. All right, if I'm factoring, I need a number times a number equals negative 14. I need a number plus a number equals negative 5. Let's see if I can think of two numbers. Doop 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 doop. Pause the video if you're not sure. Doop 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 doop. Oh, I got it. Negative 7 and 2. Ooh. Okay, so that means in factor form, I'm going to get x minus 7 and x plus 2 equals 0. And now I need to solve each part, so I need x minus 7 equals 0 and x plus 2 equals 0. I'm not explaining this part too much because, again, we've had a chance to do this multiple times in the class, and I hope that these... Okay. We got x equals 7 and x equals negative 2. So now I'm going to test those and plug them in and see if I actually get up that what I want here. So negative 2, let's plug in 7. So we got 7 plus 1 equals the square root of 7 times 7 plus 15. 8 on the left. So again, we want to see if 8 happens on the right. We got 49 plus 15. 49 plus 15 is 64. The square root of 64 equals 8. We are good to go here. X equals 7 is definitely a solution. We need to check x equals negative 2 quickly, so let's do that one. Negative 2 plus 1 equals the square root of 7 times negative 2 plus 15. That's negative 1 is equal to negative 14 plus 15 equals 1. What? That's not possible. That is extraneous. So I do have this extraneous in the wrong part. But x equals negative 2 is extraneous, x equals 7 is not. Our only answer is x equals 7. Final problem. 2x to the 3/4 plus 2 equals 10. Kind of the same thing as, remember when we did root equal a root or root equal a number to solve? It's the same thing here. So the idea here again is something to an exponent equals a number, and I think that's the only case you'll have, and that's all I'll say here. So let's go ahead and move that 2 is my point. Because I don't want this plus 2 here. I just want the parentheses with the exponent by itself. So minus 2 minus 2. I get 2x to the 3/4 equals 8. And now to get rid of the 3/4, what I have to do is I have to raise everything to the 4/3. I need to do the reciprocal on both sides. Okay? The reason I do that is because the 3's and the 3's and the 4's and the 4's are all gone, and I'm just left with 2x equals. On the right side, I'm looking for a number multiplied out 3 times. That gets 8. I think that's 2, and I need 4 of those. So add another, multiply another 2, and I think I get 16. Please check my work. And x equals 8. And for the sake of the time, that is your answer, but you would want to go back and check your work. That's it, guys. Thank you for watching, and I hope that helped.